So now it's time to derive Euler's equations here for principal axis rotation. So I'm gonna erase this other things and get to it. So again, for principal axis rotation, the axes for all of our problem are defined conveniently in the principal axes of the I matrix. So there's no off-diagonal terms. It's going to make our life so nice. So now what we want to do is we're going to say that our sum of the moments is going to be equal to our I matrix times alpha. Now we're going to take this cross product and it's going to be omega x, omega y, omega z. Because the axes that we care about, we want to make sure that they're rotating with, it's rotating with the same axis, that the whole coordinate system is rotating with the same axes that our I omega is defined in. So we're going to take this cross product, and now this term is just going to be I x x, omega x. This term is just going to be I y y, omega y. And then we're going to have an I, z, z, omega, z in the k. All right, and so we're going to set ourselves up down here to write out this cross product. All right, so that gives us omega. First, we'll do all of the positive terms of our cross product. So we've got omega x cross this in the y, and that's going to give us a k term. So it's going to be plus omega x I y y omega y. And now we're going to take this term and it's going to be cross y cross z, and that's going to be in the x. So plus omega y I z z omega z. And now we're going to take this, and that's going to be in the positive y, so plus omega z I x x omega x. And now I'm going to do all the negative terms, because now if I take this term crossed with this term, that gets me negative in this direction. So we've got omega x I z z omega z, and that's going to be in the negative j. So we've got effectively an I cross k term. And now I want j cross k term, and that's going to be in the negative, or wait, I want to go backwards, right? I want to go k cross x term, and that's going to be in the, so here we have I cross j, it's going to be in the negative k. Yeah. So yeah. Y, x, x, omega x. And now I'm going to take this term cross this term, and that's going to be in the negative I term. So now we got negative omega z, I, y, y, y. And I'm not going to forget this term here where we've got our I, x, x, alpha x, I, y, y, alpha y, I, z, z, alpha z. And this is going to be equal to the sum of the moments in the x direction, either about a fixed point or about the center of mass. And this is going to be equal to the sum of the moments in the y direction, and this is going to be equal to the sum of the moments in the z direction. Now, if you take a look at these equations from the cross products, you'll notice that here, look, this term and this term are both multiplied by omega y, omega z, omega y, omega z, omega. And now here in the y direction, we've got omega z, omega x, omega z, omega x. And then similarly, omega x, omega x, omega y here. So these terms can actually be simplified. And here's where it would be nice to have a bigger board, but we'll just erase this. And we'll couple up these terms. So we've got the sum of the moments in the x direction is going to be equal to I x x alpha, and for whatever reason the convention is to make this negative first, and so we're going to have our I y minus I x x omega y omega z, and then okay, so now we're going to have our sum of the moments in the y. We're going to have our I, y, oh, this is supposed to have a subscript, alpha, y, minus, and now the one that's negative here is IZZ, and then the one that's positive is IXX. And this is wrong. This is supposed to be a z. Yeah. And omega x, omega z. All right, and then writing the next one, sum of the moments in the z direction is now going to be I z alpha z minus, and the negative one is IXX. And the positive one, which is going to come here, is going to be I y. And now we've got omega x, omega y. And these equations are known as Euler's equations. And now this is kind of cool because just like what we normally would be talking about, some of the moments in the z is going to be IZZ alpha z, right? This is still the same as long as some combination of these are 0, right? So if there's no rotation in the x or in the y, then this is still fine. And if these two terms are equal, this is still true. And similarly now with all these other terms, right? We're going to have, if this term is 0, then we have our omega, this whole thing zeroes out, this zeroes out, and we're just left with this. We're left with this in the x direction, and if the omega y is 0, then probably alpha is also 0, so this is probably also going to be 0, and if omega y is 0, then we're left with just this for the some of the moments in the z direction. So it really is quite nice. Things drop out. Most of the time you won't be using all of these, but you'll need to know like which combination to use for your particular problem. And we'll do some examples.